Hello everybody, this is Charles Anderson. I'm just a guy from Goodwill, Oklahoma, and I've got a really great video game idea, and this is part 11 in my Java Basic series. I've got some methods running around, and we're gonna hit those and hit those hard. I guess I could do constructors and error handling because they're all methods in a way, but I guess I'll go ahead and give them special sections for themselves to help keep it all straight and such. So. Today I'm going to be dealing with methods and, Charles Anderson email address for those who wish to give me a holler. So, methods in Java. Okay, well, methods are the most important thing in programming, in my humble opinion. Okay, yeah, there is another important thing called variables, but methods, all right? Classes, right? Object-oriented programming, Java itself is based on classes and such not, and classes let us organize, the variables and methods and all that other good stuff, and classes are the foundation block of object-oriented programming. However, methods do stuff. All right, there would be no programming in object-oriented programming without them. So that's why I think methods are the most important thing. Yeah, just go figure. So yes, now, this also means methods and how they're written will be 80% of your bugs, just saying. When you do stuff, stuff can go wrong. So, we're all human. It just goes. So, just saying. Yay! All right. Oh, and of course, I'm covering the whole speech for those who are just translating, and then I'll jump in and play with it for those who are, starting off from the ground floor and working their way up. Okay, so methods in that good old Java memory model. So, code, stack, static, and heap. The method signature part of your method, goes into the static part of the heap. It's kind of like a reference value, just like a class value is its own reference value. A method signature is also a type of reference value. We don't really deal with it directly, but it is there, and it's part of the model. So. Now, the method itself, all the code that's in that method. So the method of a instanced variable from the last talk, right? Copy of it's put into the blueprint, and it goes into the stack when it's called. All right, and a static method, it goes on ahead. All that code that's written in the static method, it goes into the stack when called in line. So, like, from the blueprint over there in static, that code is just copied straight over into the stack, and then it goes on with the rest of the stuff, if the compiler optimizes that way. This is what they call inlining code. So, yeah, all the code that you write in a static method, yeah, it gets taken directly from the blueprint, bam, put onto the stack as part of the calling method. So, you write the signature, but then it swaps out that signature and the data value for the actual code. So, go figure. You can think of it like a for loop does that as well. Methods put their local variables in the stack too. So, those local variables without, public or private or protected. Well, of course, there's no public, private, or protected inside of a method, because each of the variables, they get put into the stack along with the code. So, boom. Flow control? Why, yes. This is methods, right? Just calling a method is like a jump in flow control. You have your... I'm going to refer to the stack here on this invisible section of the screen that I have here. I could go to the picture. Yeah, I'll go to the picture. Why not? Psh, why not? Oh, no, not JMonkey Engine. Yeah, there we are. Java memory model. Open with Windows Photo Viewer. Yes, thank you, Windows 8. Okay, so yeah, you got your main. It calls the function, and then that function gets put in. This. It goes and finds out what method matches this method signature right here, and pops that onto the stack, and fills in the blanks for all the missing values, and then it just keeps executing, and keeps stacking up until it's ready to start chowing down. It reaches the uppermost limit and then starts coming right back down until it hits main again, and then it goes on to the next instruction in main. Then it stacks up again and all that good stuff. So that's that flow control, because it jumps from this frame to this frame, and then for the functions that are in here, from this frame to this frame, and so you're actually jumping around and then coming back down. So yes, very much so on that flow control. And cool thing about methods, they can also return a variable when they execute. So void, I just used void in the last example, just because I didn't really need anything returned. It just needed to do something. But yeah, you can get some stuff returned back if you want. And so I'll be working with return today. The return variable is specified in the signature. So yeah, well, return type is specified in the signature. Oh, and there is always exit, which exits the current thread or program. You don't see it, especially not on main. But when working with threads, you'll be seeing this a bit more, maybe. But yeah, there is always an exit. It's just not, you just don't see it for people just running program. Scope keywords, yes, inside of a class. Method is inside of a class, so it can be said public, protected, private, and default or anonymous. Yes, anonymous. And method inside of a method, it's anonymous and local, all that good stuff. Methods are found within a top-level class on down. So method signatures contain these same keywords. Yeah, anonymous and local and default. Any method that is scoped as static gets put as a class variable and done inline, possibly, depending on the compiler. But the whole idea is one copy is shared with all instances of this class. There only needs to be one, and it's used for all of them. And they're separated by their signatures. Okay. One. Okay. One thing about signatures. Yes. Method signatures. You can actually have a method with the same name, right? But it handles different values or value types, and that changes the signature. So you can have like a whole bunch of methods with the exact same name, but as long as they're working with stuff differently, then that's considered a unique method signature. So big thing about method signatures right there. Method signatures have to do more with the name, the return type, the name, and what values it deals with for the method parameters. There we go. That makes the method signature. So, final scope keywords continued. Okay, final. This method can never be overridden, hidden. This has to do with inheritance, so I'll be covering that more in inheritance. There can be only this method signature. So if you try to make another method signature like an override or hiding, you can't do it. It's just this name's off limits. Or method signature is off limits, excuse me. Abstract. All right, abstract. Yeah, this is when it's only the method signature. You don't actually have any code written. It's just like, okay, these are the values that I want to work with, and this is, again, meant for inheritance. So it's not the implementation. This keyword means this is nailed in the air. You can't use it until you define it better. Well, yeah. Throws. The throws keyword. Yeah, something could go wrong with this method, and so we're going to try to do some, and I'm not really going to handle the error catching, so be ready for it. So error catching, heads up. Yep, native. Oh, yes, the native keyword. Okay, this one, I cannot do this in this Java tutorial series. It is a keyword, but like, say you write something in C or C++ or something else for a specific operating system. Well, Java's for all operating systems, but for a specific operating system, you have to code it up natively. Native. And so this just designates the method signature for an external method in some other language for a specific OS. So by definition, I'm calling, because this keyword's here, yes, this is a method signature and it can be called from Java. However, it refers to something outside of Java, and I don't really have that information as yet. It's advanced, and I would have to have some other programming language to be able to utilize this keyword. I mean, that I would have to show, but this is just basic Java. So, all right, and credits. This is JMonkey Engine. This is Java. My name's Charles Anderson. I'm an indie game developer. My project's Idiog. I've got an email. I've got a Twitter. And now, for those people who are just translating, your time is done. Now for those of us who wish to play. All right. Okay. Yep. All right. Don't really have to explain anything on this one. Yes, methods. Okay, static method. All right. So I'm gonna go jump over to JMonkey Engine now. Right. I've got my thing from last time. All right. Well, I've got a couple of methods written, so I can just do this. Okay. So, yeah, it fires up over in beginner Java, and we've already got a couple of methods done, and they're set as public. I'm not doing inheritance yet, and we've got our method signature, write something, right? String to use. And I've got my static version of it. And of course you can see the italics. Now, both the method signatures, right? There's one method signature. It's void here, and it's void here. Of course the names are different, and the parameters are the same though, string and string, because it only works with the string value type for the method signature. But anyway, this method signature gets put in the static as part of the blueprint. This method signature gets put in the static as part of the blueprint. And now, when you instantiate a sample class, the code inside, right? Of course, this gets put onto the stack as its own frame. And on a static, the code inside actually gets put into the frame that's actually being called right now. In other words, this code just gets swapped out directly. That's to do with optimization for the compiler, because there's only one copy of this needed, so it just pumps it into the current frame. So, new frame gets created, and just inlines this code into the current frame. So, big thing between static and public, from my understanding of the JMonkey Engine compiler. Inline. Okay. Methods put their local variables in the stack too. Oh, well, of course. So, like, if I were, well, let's see, this gets put into the stack because it's a method parameter. So, you know, when a frame gets created, this gets put into the stack, and of course, when this is swapped out in line before the program even starts, you know, this value is swapped out in line for here, and if it's referenced elsewhere too. And of course, like this is local, so that gets put onto the stack. Of course, this gets put into the stack in this frame, and in this frame, and in this frame, all that good stuff. All right, so I think that, because you really can't see it, I don't think. I mean, I guess I could do a debug session. Yeah, I could do a debug session. Yeah, why not? Show off. Okay, debug. Oh, but before I do that, I need to give it a stop point. Nope. Oh, stop. There. Yeah, that'll be good. Alright, so debug. Let's go debug this. Alright, here we go. Yeah, here's our static stuff. We got the class beginner Java. That's fired up into memory. We have no arguments from the command line, so length equals 0. Temp string, it's null, so there's nothing in it. Alright, and we're on this current line of code. Let's go ahead and execute it, so we'll step over the expression. Okay, oh yes, and of course we do have our sample class. This is a reference to the default constructor, which I'll go into. I'll go ahead and do constructors next. Why not? So, alright, that gets created. What is this? Is this not step into? Oh, step over expression. Alright, what's this? Oh, step over and step over expression. Okay, step. There we are. Okay, so now we have temp strings made. We're on this line of code. Okay, there's a breakpoint. So we have my sample class, and I just stepped over write something. So on our output, we've got yo, what's up? Come on. Oh, right. This and variables. Okay, so yeah. Okay, args is never set. Temp string. Okay, my sample class. Now inside of my sample class, we do have, because we have an instanced set, we have on the instanced side 5 and something cool, and on the static side, of course, there was my car. So there's static, and it doesn't show methods because the method signatures aren't really considered in code. All right, but let's see. Step over, step into, step out. I'm going to try step over again. Let's go to the next string. Yeah, that works. So now temp string right here is set to something cool because we pulled it from my string. And then we're going to write it. Okay. So something cool is just written. Okay. What line are we on? Okay, now we get, yes, my car. So now we head back here. Temp string is now the $sign from my car. And then, oh, yep, now we're doing the write something again. So we wrote it. And come over here to output. Yep, there's the $sign. And then again, bam, the final statement there. Yep. Okay, I'm going all over the place again. Okay, we got the $sign variables. Of course, we haven't reassigned temp string, so it's still the $sign. And so it wrote that back to beginner Java where I'm actually at. Okay, and then we do the end program, which runs the exit that you never see, and it tidies up and completes. So 3 minutes and 11 seconds to run that program, which really doesn't take that much time at all. So there, the debugger, showing a little bit of that tracing where the stuff goes. So you don't actually see where these signatures go, but they exist. Okay, and that they put their local variables in a stack, which, of course, the variables that I was showing you was the stack variables. Okay, and which are tied into where their locations are at in the heap. So, yeah. Public and private detected, anonymous and local, static, possibly inline, final abstract, rows, native. Now, there was another, oh, right, the return. Yes. I totally skipped flow control. Okay, flow control. Returning. Okay, yeah. So let's go ahead and modify this a little bit. I mean, well, don't need the break anymore. Let's head over here to sample and add a new method. Why not? Let's public. Oh, it doesn't need to be static. We'll use the instanced version. And let's go. Oh. Instead of void, let's return a int and add 2 numbers. Why not? And let's say your string int number 1 and int number 2, and let's get this puppy going. Okay, what do you grep him out? What do you grep him out? Oh, right, no return statement. So, yeah, and this is going to gripe until I return something, because here is what I need to return, is an int type variable. So, number 1, number 2. So, I'll just go, I could just say return number 1 plus number 2. There we go. It just adds the 2 number. Or if I want to be like more official and fancy about it and like allocate more memory unnecessarily, I can go int like return number, and then add another line of code like return number equals number 1 plus number 2 and return number. It works either way. This is I guess a little bit more readable. I mean, obviously, return number 1 plus number 2 is pretty dang readable, but it's a matter of style. But oh, let's use it. Let's use it. And we can say what? Let's use the instantiated. Doesn't really matter which one we use. They're both pretty much functionally the same thing, but write something. And this time we will use a function in there. So go for this string dot value of and further fold it with I wonder if I will get away with folding it this badly. Class dot add 2 numbers, 2 and what, 7? Yeah, that'll make 9. 7. And I just made a really folded statement. Alright, and there we are, 9. And the way that it unfolds on the stack would be, you know, it'll start parsing into it, and this frame gets created for add 2 numbers, and of course 2 and 7 are put in there. Then it adds them together, and then it returns it, and so you get 9, and then of course that's an integer, and then it gets converted into the string, so it becomes the string 9, and then it gets written, and bada boom, bada bing. And so yes, this is a function, but because it returns a value, it can be treated like a primitive because it returns a value. So that's how we fold it. And then of course you've got to translate it to a string to be able to be written for this function. All right, I think that's about it for that. That's returns, and you can return like a class. You can return, well, pretty much any data value of reference or primitive type. I'm not going to go into wildcard or raw yet. So, all right, I think that pretty much wraps it up. Let me check my presentation. Return void. Yeah. So return is the keyword, and it has to be of the same type as you declare. So it needs an int, and we give it an int. So there we go. All right. Derp. Final abstract. Yeah, that's that. Okay, so pretty scream time. I've been using JMonkey Engine. I've been using Java. I'm Charles Anderson, an indie game developer. My project's Idiog. I've got an email. I've got a Twitter. And hey, y'all have fun. See you next time.